Alright, there is a proof here that I'm going to skip. If I was designing these notes, this would be kind of a supplemental thing, and I'm going to skip the rest of 516, and I'm going to skip 517. Okay, it's a long proof, and I want to actually get to the meat of what we're doing. So I'm going to show you how to solve by multiplying first. Alright, first we're going to decide which variable to eliminate. Alright, then we're going to multiply one or both equations by a constant so that adding, we're going to not subtract, the equations will eliminate the variable, and then solve the system using elimination method. So that is our goal. So if we go to this one down here, to B, so we're booking through, right? I am noticing a few things, right? I am noticing that I've got x's and y's, and we can probably get one of these guys to cancel out. So let's do it. Let's get one of these guys to cancel out. Alright. I notice that, you know, I'd probably rather do the x's. Do you see these x's? That is a negative 3x, and that is a 4x. And I can make these guys opposites. I can make that negative 12 and that positive 12 by multiplying, right? If I multiply the first equation by 4, like if I do this whole thing by 4, right, and the second equation by 3, this entire thing by 3, what I'm going to get is I'm going to get x's that are opposite coefficients. So if I do it here by 4 and by 3, well, 4 times negative 3x is negative 12x. 4 times 2y is 8y. 4 times 4 is 16, right? 3 times 4x is 12x. Look, they're opposites. 3 times negative 13 is negative 39y. 3 times 5 is 15. Alright. Now if I add these equations, well, let's go ahead and do it. And they want us to reline this up, so I'll put my 8y and my 16 there. I'll put my negative 39y and my 15 here, right? I add these guys up, the x's cancel out, I get negative 31y equals 31, right? And then I get, well, it looks like I get y equals, if I divide by negative 31, we get y equals negative 1. Alright. And let's keep going just in case they, oh, they do, they have us solve it, alright? So now I know that y equals negative 1. Alright, we're going to plop that back in. So if I plug it into this one right here, right, negative 3x plus 2 times negative 1 equals 4. Negative 3, 2 times negative 1 is a negative 2. We add 2 to both sides to get rid of that negative. Plus 2 we get 6. And x would be negative 2 for a system of negative 1, negative 2. Alright, so I am not going to check these by graphing, and I don't need you to check them by graphing either. But let us keep going and show you how to do these next page, and then we'll save one for the word problem on the back. Alright, so we're going to check them in our head. What I want is I want something to cancel out. And I like to pick things with opposite coefficients. Like this is a negative and that's a positive, and they can both be turned into negative 6 and or positive 6. So I'm going to multiply this entire top by 2 and this entire bottom by 3. And you'll notice my x's will cancel out, right? 2 times negative 3 is negative 6x. 2 times 4y is 8y. 2 times 12 is 24. 3 times 2x is 6x. 3 times y is positive 3y. And 3 times negative 8 is negative 24. And when I add these, I get something beautiful, right? The x's cancel out. I get 11y equals 0, which is kind of nice, right? Because now my y is 0. And then it really doesn't matter which one I plug this into, all right? I can plug this into either equation at this point in time. And I usually pick the ones with the smallest numbers, all right? So if I do that, if I pick, I don't know, this guy right here, if I pick 2x plus y equals negative 8, and I plug in a y of 0, 2x plus 0 equals negative 8, which is just 2x equals negative 8. Let's just divide by 2 here. We get x equals negative 4. So my ordered pair is -4, 0. Let's just check this by plugging it back into the other equation. Alright, this one right here. So if I go -3x plus 4y equals 12, and I got -3 times -4, and 4 times 0, and that gives me 12 equals 12. It checks out. Alright, no graphing. Alright, you don't have to graph these. I think you know how. Ooh, it seems just a little off focus. Alright, so the same thing here. I want to get rid of my y's again just because that's negative and that's positive. So I'm going to do the exact same thing. I'll multiply this by 2 to turn that into 6y. Multiply this by 3 to turn that into -6y. If I multiply through, I get 2 times 2x, which is 4x. Positive 6y equals -2, right? 3 times 5 is 15x. -6y and -36 by the look of things. We add and our y's cancel off, right? I get 19x equals -38. Divide by 19, divide by 19, and I get x equals -2. I circle it. I'm just going to plug it right back into there. Alright, I got 5 times -2 minus 2y equals -12. Which is -10 minus 2y equals -12. And this is pretty much the same thing we were doing yesterday at this point, right? We get -2y equals -2 and y equals 1. So I got an ordered pair of -2, 1, and I'm going to plug it back into the original, right? This one, the one we didn't use to solve. Let's see if it works. 2 times -2. 3 times 1 equals -1, and that works out. -4 plus 3. -1 equals -1. Checked. So we got one more page to do. Where are we at? 7 minutes? Let's do it. Let's see if we can pull this off. You know what? There's 2 problems. Let's not do it. Let's do one more video. Talk to you guys soon.